Hey everyone, how's it going? In this video, we are going to go over math in Python. Now, I know what you think. Math sucks or math is boring, and kind of agree with you a little bit. Hey, people like math sometimes. But just because you maybe don't like doing math all that much doesn't mean you might not have to do math in programming. Because believe it or not, but math is very useful in programming. Especially if you ever want to do something that's like AI related, you're going to need to know how to do some math, or at least how to do it in Python, not necessarily on paper. So I wanted to make a quick video to go over all of the math related things we can do in Python with some simple examples. So let's get into it. All right, so here we see we have students, and if we go ahead and just run this here, we can see that students is 10. Pretty great. By the way, this is a Jupyter notebook in Visual Studio Code. I will have a link to this in the description down below, as well as just a normal Python file that you can use instead if you don't want to use Jupyter notebooks. But I think it's really handy to be able to see outputs like this. So we're going to use it for here. All right, so we have students here and it is equal to 10, but what if we want to add a value to students? Well, we can just do students equals students plus 1. And then if we go ahead and run this, we can see now students is 11 because just by the way, this right here is effectively doing print students. Let me just make that super clear. All right, so this is great. But we can actually shorten this. We can just comment this out and do students plus equals 1. And then this will add 1 to students, and basically whatever's after the equals sign is how much we're adding. So in this case, it's the 1. So if we run this again, we get 11. If I add this, make this a 5, run it, we get 15. So we'll keep this at 1, but let's also comment this out. All right, so we can also subtract things from students. So we can do students minus 1. If we run this, we get 9. But the same thing is true with the plus, or with the addition. We can do minus equals 1. And honestly, it's a lot shorter, so I like doing that one way more. But what if we want to multiply students? Well, we can also do that. We can do students equals students times 2. And if we run this, we get 20. But believe it or not, you can probably see where this is going. Students times equals 2 also works. So now we can also get 20 when we do this. Finally, you probably can guess what's next. We can do students equals students divided by 2. And the / is what division is in programming. And the star, the asterisk, or the shift 8 is multiplication. So if we run this, we can see that we get 5.0. And just as before, if we do students / equals 2, this is also dividing by 2. So we're going to get the same thing there. All right, so you've probably seen these before, but one maybe you haven't seen is that you can do students equals students * 2. And this is effectively doing students to the power of 2. So if we go ahead and run this, we get 100 because it's doing 10 times 10. If we do 3, what do we get? 1,000. Great. But we can also do this shorter. We can do students **, which is very hard to say, equals 2. And if we run this, we also get 100. So there are instances where I think it actually makes a lot more sense to do it in the long form, because I think things like these, like this especially, kind of just doesn't look right. It looks like it should break, but so it's kind of a little bit confusing to see, but to each your own. All right, so we'll also notice that say we do students divide equals 3. If we do this, we get 3.33, right? Now that's great. But if we do divide equals 3, we get just 3. And what that's doing is that's taking the floor, or basically rounding down, of whatever the result is. So we get 3 here. You can also do this in the long form, where it's students equals students divided by 3. All right, but what if we want just the remainder? So we can actually do that doing students equals students %3. So % is actually called the modulus, or the modulo icon or symbol. And what this is going to do is it's going to divide students, which is 10, by 3. And whatever the remainder is, it's going to provide that. So if we run this, we should expect 1. Because if we do students divided by 3, we're going to get 3.33, but that 0.3 actually just means 1 because we're dividing it by 3. So there we go. Some simple arithmetic using Python. Now, let's move on to some helper things we can do. Okay, let's create a new code block here. And in this case, we're going to define a couple variables. We're going to say x equals 9 point, just a bunch of numbers, and then y equals, we'll say 11. Now, what if we want to print x, but we don't want all of this stuff. We don't want all these other numbers. We just want it to be just, is it a 9 or a 10 or what is it? Well, we can do round. And if we round x, it will round down to whatever the value is. So it'll round down. If this is 9.5 and we run this again, it will round up to 10. So if it's 4.9, it will round down. And as soon as it's 5, I believe it will round up. So there you go. Now, if we just keep it as whatever this random stuff was before, we can also say at what point do we want it to round. So we can say for 4 digits. So if we do this, now it will round on the 4th digit after the period. So it's rounding here. So if this was a 9, oops. So if this was a 9, then we can go ahead and run this and it will round up to a 5 rather than a 4. Pretty neat. Another thing we can do is get the absolute value of something. So if we do this for x, this is not going to be that interesting. But if we change this to negative 9.217 and run this, we get a positive version of this. So this is really useful where if you're not sure if you're going to have a negative or a positive number, but you just always want to make sure that it is positive, you can take the absolute value of the argument and it will make sure that it's positive. So pretty handy. We're going to change this back to be positive here and comment this out. Now you can do another cool thing where you can say the power of something. And this is basically the same thing as, x to the power of 3 or something, where we can say 2 to the power of 3. And if we run this, we get 8 because this is saying 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So that works awesome. And yeah, pretty great. We can also determine whether something is bigger than another something using a helper method. And this is actually super useful. So in this case, we can get the max value between x and y. Now, the reason this is useful, sure, you could just create an if statement and say if x is greater than y, then return x, or if, or else return y. You can do that, but you can just use this built-in thing and it kind of just does that for you. So in this case, we get our 11, and there's also a min. So if we do print min of x and y, we can get the minimum value, which is in this case is 9.217. But you can also add multiple variables here. It doesn't have to just be 2. So we can add a 3 or a 4 and run this and we'll get the 3. So this is super useful because it allows you to clamp values really easily using max and min. So for example, say we want something to be no lower than 5 and no higher than 10. So all we have to do is do print the max of 5 and the min of x and 10. So what's going to happen here is the min is then going to clamp x to something between whatever the value is of x and 10, meaning if it's higher than 10, it's going to take 10. And then this is going to return whatever that is. And then it's going to take the max of 5 or whatever the value that's returned from the min is. So in this case, we're going to get 9.2, but say x was 1,000. Well, now we get 10. What if x was minus 50? Well, now we get 5. So this will ensure that you can clamp a number, which you might not know what it is, within a certain bounds, which is super handy. All right, moving on. Let's create a new one here, and we are going to go ahead and show off some math helpers. So we're going to need to import math. Let me scroll down a bit here. And we're going to print off some cool things. So what about pi? Everybody knows pi is 3.14. Probably. I think it's 3.14156 or something like that. But we can do math.pi. So you don't need to know that stuff. 159. I was off. So it only knows it to this. If you need it, further than this, then you probably should just copy it from somewhere. But this is probably good enough. Another super useful one, especially if you're doing like physics, is math.e. Personally, I don't know what you use E for, but it's there. So if you want to use E, go for it. So we're going to comment this one out. You can also get the square root of something, doing math.square root. So say we do the square root of 16. Square root of 16 should be 4, because 4 times 4 is 16. But there you go. Another couple helpful things is, let's just redefine our x here, is x equals 9 point a bunch of numbers. And we'll say print math.ceil of x. And if we do this, it's going to take whatever x is and round up. So kind of like we had round before, which was something that wasn't included within math. Ceil allows us to round up no matter what it is. So it could be 9.00001, and it would still round up to 10. Now, if we do math.floor, it does the exact opposite. It will round down no matter what. So again, these are kind of useful things where you can ensure that you're going to either clamp values or ensure you're getting an absolute value or a number that doesn't have an integer instead of a float or something like that. So these are pretty handy things to be able to know how to do. All right, let's move on to some algebra. Everybody's favorite stuff, right? All right, so let's define some values here. We'll do a, b, c equals 1, -3, and 2. And then let's define a function. We'll define our function as def f of x, and it's going to return a times x squared plus b times x, and then plus 2. So basically, this is actually equaling x squared minus 3x plus 2. So one thing that we can do with this, that's kind of cool, is we can just run the function, right? Like we can say like, okay, well, what is f of 3, right? And if we run this, we get 2. Okay, cool. What is f of 5? 12. Okay, great. So it's kind of neat that like f of x is just literally a function, right? That's literally what f of x means. It's something where x is unknown and you can provide x to something and then you can set it. But a lot of things that you end up doing within algebra is trying to find out what is x, right? What is x, where typically the value of this is going to equate to 0. So in this case, we would say 0 equals, and then this. So we can just do this ourselves to try and figure out what x would have to be in order for it to equal 0, this equation. So let's just go ahead and do that manually real fast, and then we'll kind of go from there. So in order to do this, we kind of know, if you've done algebra before, you'll probably know that we kind of need to create two versions of x, because we want to be able to do x plus or minus. I'm going to assume minus because we have to get this one here, minus something, and then x minus something. Now, the reason for this is because when you do multiplication for this, I'm sorry if I'm boring you, but remember you do like x times x, so that would be x squared, and then x times something, which would be minus x minus whatever the number is, x, and then minus whatever the number is, x again, and then this minus whatever the number is would multiply by this number as well to get you positive 2. So basically, we need to figure out what adds to minus 3 and multiplies to 2. I guess I should say positive 2. So pause this right here and let me know if you can figure that out in the comments. So drop a comment down below. All right. Okay, fine. Okay, so the answer for this is minus 1 and minus 2. So for the reason of this is because x times x is x squared, and then x times minus 2 is minus 2x. So we get like x squared, then minus 2x, x, and then minus x, and then plus 2, because if you do minus 1 times minus 2, it becomes positive. And then if you just collect these together, we basically get this value here. So what that means is that you might be confused, like, okay, but weren't we trying to find what x is? Like, how does this solve anything for x? Well, what this actually solves is that x can actually be one of two values here. So x can either be whatever makes this 0 or whatever makes this 0. So x can either be 1 or 2. And we can actually verify that really easily, right? If we just do what is x squared, if it's 1, well, it's 1. Okay, and then minus 3 times 1 is 1. Or sorry, it's 3. And then plus 2. Okay, well, this equals 0 because it's minus 3 plus 3. So 0. Okay, great. And then what about the 2 example? Okay, well, it's 2 times 2 is 4. Minus 3 times 2 is 6. And then plus 2. And then that also equals 0. So that's awesome. But maybe you don't like math, or you don't remember how to do this stuff, or you can't figure out what these values are going to be, and that's totally fair. So there's actually a pip package that kind of just does this for you. So let's take a look at that. All right, so this package is called Simpy, and if we go ahead, which is kind of funny, and we're going to, from Simpy, import symbols and solve. So all we have to do here is just say x equals symbols, x, and then we're going to define our equation. And you can make this anything you want here, but we're going to define this here. And when I say anything you want, I mean the variable can be anything you want. And then we can print our solve of the equation and x. And if we go ahead and run this, we can see we get the values 1 and 2. Way faster than doing all of this by hand. So pretty cool. But again, I think that just that you can do this itself is just kind of really neat by itself. All right, moving on to calculus. Now, I am by no means a master of calculus because, again, not a huge fan of math. But calculus is super, super useful, especially when you get into like machine learning and stuff like that. Because believe it or not, derivatives really important in machine learning. So let's start off by graphing a function. I think that seems pretty cool. So let's go ahead and I'm just going to copy in some code here. And we're going to do kind of the same thing that we just did before. We're going to say we're creating our function of f of x, and it's going to be equal to, let me move these imports up top. Oops. And it's going to be equal to 2x squared plus 6x plus 11. And then we're going to do a couple of things here. The first thing, I can get rid of this, but this is another way that you can do this if you want to, rather than this linspace. Linspace will create these evenly spaced numbers over an interval. It's honestly, I don't know the difference between linspace and a range. If you do, or a range, if you do, drop a comment if you know what the difference is, but they seem like they're kind of the same. All right, so we're going to go ahead and run this, but again, we've created our f of x, which is just like a function. And then we are creating a bunch of these values, and then we're going to plot these values using f of x and this linspace. So if we do this and we do plt.show, we can run this and we can actually get what does this look like. Pretty cool. So we actually just created a graph based off of this arbitrary function that we created. So that's really cool. But what if we want to figure out what the derivative is of this function? Well, if you've never done calculus before, the derivative is the slope at a specific point on a graph. So a slope you can usually figure out a slope because it's like, okay, what is from here to here? And then you do the whole like rise over run thing. What is the change between, when x is 2 and x is 4, and then what does that equal? And then you can get your slope and you're good. But that's an average slope because this isn't a line, this is a parabola, right? It's a bending line, a bendy line. So because of that, you can't really get an accurate one. But what you can do is determine the slope at any given point. So in order to do that, all you have to do is basically determine what is the value at f of x, and then what is the value of f at x a little bit higher. So we can simply just do, so just to kind of make it clear here, we're going to do f of x plus h, which is just some very small value, minus f of x, so without the h, and then we're going to divide it by h. And this is going to give us the derivative of whatever x is, of wherever x is. So it'll be the d of dx. So let's create these values. So we have our x linspace here, which we're not going to use here, but we'll just do let's do x1 equals 3, and then we can do print, and we'll do f of x1 plus, I didn't define h equals 0.0001, and then h, and then minus f of x1, and then divided by h. So if we go ahead and run this, we will get our graph, and we will also get this 18.000000, well, 0.000002. I was saying so many zeros. But anyways, so the derivative of this function here, when x is 3, so right here, is this 18.00 whatever, but it's effectively 18. You'd probably just round down to be 18 here. So what does that mean? That means that the slope here is a line that's going up, and it has a slope of 18, meaning if it was negative, it would be the other direction and whatnot. But you can also graph that line. So in order to do that, it's a little bit more complicated because we need to define what is the actual slope function. So the slope function, I'm just going to kind of copy it over here, but if you wanted to, you could kind of determine what the derivative is of the function. I'm not going to do that because that's hard. And we're going to say that the slope is 4x plus 6 because I've already done this before, but I can do the derivative here, but basically it's just you're going to take this 2 down so that it's going to be 2 times 2x, and then you're going to take the 1 down, which there isn't anything, and multiply it by the thing at the front, which will be plus 6, and then plus 0, which then equals 4x plus 6 is the derivative of this function. If it was a complicated function, I can't do that in my head, just so you know. All right, so this is our slope here. All right, then I'm just going to copy some stuff over because it's going to be faster than typing it. So we're going to define our y1 as f of x1, which is 3. Then we're going to create a line function, which is going to take in an x value, and it's going to take in the x1 and the y1, and then it's going to call our slope for this x1 value, and then it's going to multiply it by x minus x1, so the difference, and then we're adding y1. All right, and we're almost there. We're going to go ahead and I'll just copy all this and paste this in here. And now what we have is we're creating an x range, which is just the range for our x1. So x1 minus 1 to x1 plus 1. So that we can basically define where on our graph do we want this line to go to of the slope. And then how long, or what are the increments of this? So just 10. And then we're going to plot this using x1 and y1. And this is just going to be a dot. Excuse me. And then we are going to plot the x range, which again is this line, using our line function. And so just to be clear here, plot takes in a bunch of arguments. Can I go to this? Yeah, I can go to this. Cool. So it's going to take in the float, so the value, which is this x range, and it's going to loop over all of these to get our value here. So let's just go ahead and run this, and we can see what we see. Oh, my bad. I already did plot show up above. Wait. There we go. So here we get our line. And right here, this is our slope. So this has a slope of 18. And just to show you that like I'm not lying, I guess, we can actually, let me bring up a little calculator here, a derivative calculator. I already just did this just because I didn't want to say I was lying. So this is our function here, which is our 2x squared plus 6x plus 11. And we can go down here and you can see this is where we get our 4x plus 6. And if we go down and check what this is here when x is 3, we get our 18. And that is what our line kind of looks like. Our graph is more spread out, so it's kind of shifted a bit. But yeah, so pretty cool. So that's it for today. That's how you can do a bunch of different types of math in Python. Now, I would really recommend that if you are going to practice doing math in Python, that you should just practice the first things first. You're just getting used to adding values, subtracting values, getting the modulus of something, and maybe look up some simple examples, or maybe I can think up some and put them in the comments below, or maybe a community post that maybe you can post your solution to if you want in the comments. But try and get used to using that. Once you do that, try and figure out some ways where you can try and use like the absolute values, the max or the mins. And then finally, that's probably all you're going to need to do. But I think if you do need to do algebra, the SIMPy module is really handy. But I think being able to just like think of it as a function, like a literal Python function, is really cool, and maybe a different way of how you can wrap your head around some math if math is giving you some trouble. For me, I needed to go to after class tutoring, not tutoring, but like well, I guess kind of tutoring, for linear algebra and calculus for like, I spent hours there. So I'm not super strong in math myself, but I know that, if you are struggling yourself, you can definitely get through it. It just takes a lot of work sometimes. But everyone's different. Maybe you excel at math and you don't even have to sweat it at all, but we'll see. All right. Thanks for watching. And remember, I'm Jake. You're awesome. And this has been Math in Python. Cheers.